to. My super duper editing program, Adobe Premiere, has been stripped from me. So I'm having to make lo-fi videos, which means they're low in production value, and I'm going to make mistakes. But I think someone has tried to make me stop making videos, so I'm going to make some videos. You know what I'm talking about? So let's keep going. This one is fascinating. It's called The Mysterious Four-Dimensional Iron Oxide Explained. We found this at Eureka Alert, who claims to be the global source for science news. Isn't it interesting, right? Iron oxide, dust. I don't know if you guys remember, I like to use that phrase to be funny sometimes. Iron oxide dust. Because there was a Nibiru video where a genuine guy was talking about seeing Nibiru, and he sounded genuine correct. He said it was just covered in iron oxide dust everywhere. I always remember his voice, you know? So that's what that reminds me of. Let's keep going. I'm sure this doesn't have anything to do with Planet X or Nibiru. Scientists have explained the unusual four-dimensional feature of iron oxide. Holy crap, you mean to tell me Planet X has 4 dimensions? I just crap my pants. Give me a second. I gotta wipe up. That was metaphorical. An international group of researchers, including Russian scientists from the Moscow State University, has been studying the behavior of the recently discovered Fe405, or we call it iron oxide. The group has succeeded in describing its complex structure and proposed an explanation for its very unusual properties. The article appeared in the current issue of the Journal of Nature Chemistry, which you got to pay for, I believe. You got to pay for science you already paid for. That's crazy. That's capitalism. 2016. But carry on. The scientists discovered that when Fe405, iron oxide, is cooled to temperatures below 150 K, it goes through an unusual phase transition related to a formation of charge density waves, which lead to a 4-dimensional crystal structure. That's cool, man. Crystals are cool, and crystals are powerful. What if, the core of Earth was actually a liquid crystal instead of like a liquid iron? Well, I guess iron oxide is both metal and crystal, so that's crazy. You know what I'm saying? Like some armor like that, or imagine if you can make spaceships out of crystal iron silicate. That'd be great. That'd be groovy. Let's continue. Artem Abakumov, senior researcher at the faculty of the Department of Electrochemistry at the Lomonosov Moscow State University, and one of the paper's authors, said that the further study of this material would be rewarding from the viewpoint of a fundamental understanding of the interconnection between magnetic and crystal structures. What did Tesla say? If you want to understand the universe, it's all about vibration and frequency. You know? So yeah, iron oxide bringing good vibrations. The origins of this research date back to 1939, when the German physicist E.J.W. Verwey first discovered that the iron oxide Fe3O4, commonly known as mineral magnetite, had a strange phase transition. Say what? Magnetite, in its normal state, is a relatively good electrical conductor. But when cooled below 120 K, its conductivity markedly decreased, and the material practically became an insulator. Scientists suggested, no they don't, scientists guessed. Oh, I love it when they do that, man. Like, that's so awesome. You know, and scientists guess and then say, this may have happened. And I'm like, oh, great, dude, this may have happened. Scientists guessed the reason for this transformation explained that below 120 K, the iron atoms arrange themselves into a kind of ordered structure. Oh my God, it's a iron crystal, new world order. Once we get below 120 K. If that happened to Earth, I think we'd be in a new world frozen order, man. And nobody would be bitching because everybody'd be dead. In this structure, the electrons are denied to move freely within the material and act as charge carriers, so that this oxide even becomes a ferroelectric. Whoa. That sounds sexy. I don't even know why. Even so, the scientists could not explain what exactly changes in the structure. Something which physicists have spent the last century attempting to discover. Even so, the scientists could not explain what exactly changes in the structure. So it's cool to have different vibrations and frequencies at different temperatures? All that could be suggested was the phenomenon was related to the presence of iron atoms in two different oxidation states, balances 2 and 3, and their consequent ability to form ordered structures. I know when we talk about oxygen, we're like, hey, it's great. We love it. It gives us life. We breathe. I agree with that. But also, I've been informed that oxygen causes things to deteriorate. So at the same time, the oxygen's killing us, man. Like it causes rust and stuff like that. So, like many things in life, has a good side, has a bad side. But I like oxygen, man. You're cool with me. The answer to this question was found only recently, in 2012, dun dun dun, when a group of researchers led by Professor Paul Atfield of Cambridge University managed to synthesize high-quality magnetite single crystals and decipher their structure. Scientists showed that, just as had been suggested earlier, a so-called change in the ordering had occurred, in which 2 and 3 valent iron atoms arrange themselves into groups of 3, which are called trimerons. Whoa, we just learned something today. You are welcome. High five over the internet. Boom. The authors of this article, which had been published in Nature Chemistry, decided to look at different iron oxide, Fe405, which had only recently been discovered by an American research team. It's an unusual oxide that can only be formed at extremely high temperatures and pressures, meaning that it is not to be found on Earth's surface and exists alongside other oxides containing even greater levels of oxygen. As is now believed, at tremendous depths of hundreds of kilometers below our planet's surface. Oh. Okay, this is interesting because the other day I had an article saying that there was a star that was just spewing oxygen. So this would make sense for the high oxygen levels. And that's crazy. So, okay, 120K, it's heat, it's not freezing, and we'd all be dead at 120K, I imagine. I don't know, maybe evolution would work fast, and we'd all be like on fire, but alive. No, that doesn't sound right. Yeah, so it sounds pretty cool, and the fact that they break up into threes, somebody can claim divine geometry or whatever. I've never looked into that. I'm bad at math. When examining the behavior of this oxide, which was obtained by Sergei Obzhinikov in the group of Dr. Leonid Dobrovinsky of the University of Bayreuth in Germany, who is a specialist in the synthesis of materials at high pressure. Scientists discovered that this oxide has a phase transition phase very similar to that noted by Verwey in magnetite. It differs, however, in occurring at different temperatures, and the configuration of the structure obtained is much more complex. We have found that here, just as in magnetite, when cooling to lower than 150K occurs, an unusual structure evolves. It's something of a mixture between standard charge density waves, forming dimmers, chains of iron atom pairs, which have foreshortened interatomic distance. And what? Everyone commented. And the situation with the trimerons that was observed in magnetite. This was very complicated in the case of Fe405, what's known as a inconsortally modulated structure, in which we can't identify three-dimensional periodicity. However, the periodicity can be observed in a higher dimensional space. Say what? However, the periodicity can be observed in a higher dimensional space. Well, I bet I'd be even cooler in 4 dimensions, man. In this specific case, the 4-dimensional space. When we mention the 4-dimensionality of these such structures, we're not actually talking about the existence of these oxides in 4 dimensions, of course. Oh, man, why are you taking the fun out of it? This is just a technical construct for the mathematical description of such highly complex ordering. Well, if I'd have known that, I don't know if I'd have read the article. Just kidding. It's still pretty cool, man. Having a metal crystal is neato. Makes me think about writing Dungeons and Dragons type movies again. Despite clear similarities between the behaviors of magnetite and iron 405, the charge-ordered structure of iron 405 remains centrosymmetric, without exhibiting any ferroelectric properties. The special interest which scientists have in iron 304 results from the fact that magnetite belongs to a class of materials known as multiferriox. Whoa. In which two kinds of ordering are seen at the same time. Magnetic and electric. There you go, ladies and gentlemen. It's a magnetic and electric universe of fire and ice. But we knew that already, right? Right. If these two different orders become coupled with each other, then the effect of the magnetic field on the material can alter its electric polarization. Or, conversely, magnetization changes being affected by electric field. If this happens, says Artem Abakumov, then we get a bifunctional material that's of interest not only for the fundamental physics viewpoint or solid-state chemistry, but also in terms of how it could be put into practical use. It could be used in sensors, for example, in magnetic field sensors. The only drawback is that normally a coupling of a magnetic and electrical order is pretty weak, and it only appears at lower temperatures. Comparative analysis of the crystalline, electronic, and magnetic structure of iron 405 and magnetite will give us a better shot at studying the relationship of the magnetic and electrical order in these kinds of materials. Well, fascinating. I know it's cool looking, man, you know. That's pretty neato. Yeah, I'm just happy I learned about ferric and crystals and metals living together in harmony, in order, and happiness. That's kick-ass, man. All right, well, I hope you learned something today, and I hope I get my super badass editing program back as soon as possible, which will be later in the day. So, enjoy these while they're around. All right, peace out. Stay cool. Hello and welcome to Thor News Technical Difficulties Day 2. My super duper editing program, Adobe Premiere, has been stripped from me, so I'm having to make lo-fi videos, which means they're low in production value, and I'm going to make mistakes. But I think someone has tried to make me stop making videos, so I'm going to make some videos. If you know what I'm talking about? So let's keep going. This one is fascinating. It's called The Mysterious Four-Dimensional Iron Oxide Explained. We found this at Eureka Alert, who claims to be the global source for science news. Isn't it interesting, right? Iron oxide dust. I don't know if you guys remember, I like to use that phrase to be funny sometimes. Iron oxide dust. Because there was a Nibiru video where a genuine guy was talking about seeing Nibiru, and he sounded genuine correct. And he said it was just covered in iron oxide dust everywhere. I always remember his voice, you know? So that's what that reminds me of. Let's keep going. I'm sure this doesn't have anything to do with Planet X or Nibiru. Scientists have explained the unusual four-dimensional feature of iron oxide. Holy crap, you mean to tell me Planet X has 4 dimensions? I just crap my pants. Give me a second. I gotta wipe up. That was metaphorical. An international group of researchers, including Russian scientists from the Moscow State University, has been studying the behavior of the recently discovered Fe405, or we call it iron oxide. The group has succeeded in describing its complex structure and proposed an explanation for its very unusual properties. The article appeared in the current issue of the Journal of Nature Chemistry, which you got to pay for, I believe.